Okay, now that we've talked about formula writing for binary ionic compounds, let's talk about the next one, which would involve polyatomic ions. So as the name suggests, poly, meaning more than one, multiple. Atomic has to do with atoms. Polyatomic ions, then, are ions made of more than one atom. So they are molecules that carry a charge. As you'll see here, we have a few examples. SO4 2-, sulfate, CO3 2-, carbonate, NH4+, ammonium, NO3-, nitrate, and C2H3O2- is acetate. Okay, I don't expect you to memorize the names of these because on the back of your periodic table, which you'll have in class, or if you're online, you can just look these up. The names are always available to you, but the one that we're going to use in this example is right here. So, what is the formula between sodium and nitrate? Okay, what is the formula between calcium and nitrate? So, remember the rules that we talked about last time. It's the same process, but instead of using simple binary ions, you're going to use polyatomic ions in this case. So I'll give you a moment to give this a try, pause the video, and press play when you're ready. Okay, so let's talk about this. For this first one, sodium, as we know, has a +1 charge. And then nitrate is NO3-. Okay, remember that this 3 only pertains to the oxygen. There's 3 oxygen and 1 nitrogen in this polyatomic ion. What we want to do now is combine these two in such a way to make a neutral compound overall. That would be simply NaNO3, because each brings in a 1 charge, whether it be plus in sodium's case or minus in nitrate's case. And this is a neutral compound. That's called sodium nitrate. The formula between calcium and nitrate is pretty simple as well. Calcium has a 2+ charge. As we know, it's from group 2. Nitrate is NO3- again. So how many of each of these would we need? We would need 2 of the nitrates. And the way that you write that is a little bit trickier, but it should make sense. So Ca parentheses NO3 parentheses 2. Okay, so instead of just having what we're used to is putting the subscript at the end, we have to include these parentheses so that the 2 pertains to the entire polyatomic ion. So now we have a 2+ charge balanced with 2 1- charges for a total of 0 charge. This is neutral, and this is calcium nitrate. Okay, that's pretty simple. I think some more practice will make it more solidified. Again, that's what I have there. Some common polyatomic ions. There's no need to memorize these, like I said, but these are the ones that we're going to use the most, for sure. Okay, so take a look at those. Those are things that we're going to use pretty frequently, but you can always look these up yourself. Let's go over naming ionic compounds with these polyatomic ions and with the Roman numerals from the transition metals. So this is going to be a review of everything. Go ahead and take a moment to combine these cations with the anions in such a way that you get a neutral compound for the formula and then give it a name. Okay, we went over the naming last time, and it's really the same thing this time. If you have a polyatomic ion, that's a good thing because you just used the name of it. There's no need to change the N to "ide." So go ahead and give this a try, and then pause the video and press play when you're ready for me to go over the answers. So hopefully you gave this a shot. What we have here is calcium 2 plus and hydroxide, which is a -1 charge, coming together in a 1-to-2 ratio. Remember that the parentheses have to be here if you're going to show that there's more than one of these polyatomic ions. Okay, this negative charge pertains to the entire thing. So you have to have 2 of those to balance with the 2 plus from the calcium, and this is called simply calcium hydroxide. You just name both of them. In the next one, we have barium 2 plus and SO4 2 minus, which is the sulfate ion. Those come together at a 1-to-1 ratio, so it's BaSO4 with no subscripts needed. And this would be simply called barium sulfate. You just name the two as well. The next one we have is NH4 plus, which is ammonium, and Cr2O7 2 minus, which is dichromate. Okay, again, you don't need to memorize the names of these. You'll get to know them pretty well. NH4 has a +1 charge, so you need 2 of those to balance with the 2 minus charge from the anion. So it would be NH4 parentheses 2 Cr2O7, and that is called ammonium dichromate. Again, you just name the two as they're listed. Okay, this one was silver. Silver has a +1 charge. Acetate here has a -1 charge. Again, you just combine them in such a way that you make a neutral compound overall. This would be silver acetate, AgC2H3O2. Okay, that's silver acetate. And then the last one we have here is iron 3 plus. Okay, so this is the iron that has a 3 plus charge. We have sulfur with a 2 minus charge, and they come together in a ratio that is Fe2S3. Okay, the least common multiple between 2 and 3 is 6. So we need 2 of these, multiply this one by 2, multiply this one by 3 to get 6 on each side. This would be +6, this would be -6, and those cancel to make it neutral. Fe2S3 is the formula here, and that is called iron 3 sulfide. Okay, you have to use the Roman numeral 3 to indicate that you're using the iron 3 plus. Otherwise, we wouldn't know that it's iron 3 plus, it could be iron 2 plus. Okay, so that's iron 3 sulfide. There's going to be another practice for this. Make sure that you do it and you watch the key video if you're online, or we'll go over it in class probably. Okay, so let me know if you have any questions about this, and thanks for watching.